So let's do an example of this. I'll introduce some notation now that we'll see more and more as we move through this module. So we have an initial stock price of S. We're going to assume a risk-free rate of 8%, a dividend rate of 0. H represents the length of the binomial period, so here it's 1 year, and we have a strike price of K. So in our model, we're going to assume that the 41, over the course of a year, the 41 price can go up to 60 or down to 30. We'll worry in a moment about how one develops this model, but let's just assume those are the only two possible states of this stock in 1 year. Now again, we're going to look at two portfolios. Replication always involves looking at two portfolios and determining that they have the same value at maturity. So in portfolio A, we're going to just go long a call option. Portfolio B, we're going to buy 2/3 of a share of the stock, and we're going to short, or borrow, $18.46 at the risk-free rate. Now, where does $18.46 come from, and where does the 2/3 come from, we'll see in a subsequent module. But let's just take it as it is. What are the costs? Well, we don't know the cost of portfolio A because we don't know what this option should cost. But portfolio B, we know what it costs. It's simply 2/3 of the price of the stock minus the short position. It's going to cost us $8.87. Now, if we go to maturity, we'll observe that, in fact, the payoff in both states are the same. If the stock price is 30, both portfolios have a value of 0. If the stock price is 60, both portfolios have a value of 20. So once again, we're in that situation where we have two portfolios that have the same value at a maturity point. Consequently, they must have the same value at time 0. Since we know portfolio B cost $8.87, $8.87 must be the price of the option. So portfolio B is called a synthetic call. We used that term earlier when we were working with put-call parity. It's called a synthetic call because with that combination of stock and T-bills, we can synthesize the payoffs of the call option. This particular option is said to have a risk of 2/3 shares. That 2/3 is an important idea in option pricing. It's called the delta of the option. The delta of an option is a measure of how much price sensitivity the option has to the stock price moves. And so this option has a delta of 2/3. Let's look at another example. And in this example, again, we have many of the same parameters. It's a 41 price stock, 8% risk-free rate, no dividends again. It's still a 1-year period and a strike of 40. But we're introducing a new notion here, and this is one that will come up importantly later. Sigma, the standard notation for standard deviation, is going to be a measure of the variability or the volatility of stock price. And we will see that the two prices, 59.95 and 32.90, each come from the original price along with this volatility measure. And we'll see that in a few moments. We're going to repeat the same analysis. Portfolio A will buy a call. In portfolio B, we now need 0.736 shares of this stock, and we need to borrow $22. That'll cost us $7.84 approximately. Same analysis. Both portfolios have value 0 in the low price state or $19.95 in the high price state. Have the same value at time 1 year. They must have the same value at time 0. We conclude that this call option must have a value of $7.84. Again, we've created a synthetic call with stocks and T-bills. And again, we observe this so-called delta of the option. In this particular case, the delta of the option is around 0.74, and that's a reflection of the price sensitivity of this option to changes in the stock price.